So in the first video that you watched today, use Pythagorean theorem to solve for a hypotenuse. Use a squared plus b squared equals c squared to solve for a hypotenuse, where a and b both represent the legs of the right triangle and c is the hypotenuse of the right triangle. So I wanted to make a little video where we solve for the legs because it's a little different. So in this right triangle, we're given this leg 12, but we're asked to find the other leg, x, and we're told that the hypotenuse is 13 units long. So using that information and using Pythagorean theorem, we'll set up our problem like this. X squared plus 12 squared equals 13 squared. X squared plus, 12 times 12 is 144, equals 169, because that is what 13 times 13 is. Now, when you find a hypotenuse, all you have to do is add the two numbers that are over here. But now that we're finding a leg, we have to subtract. We're going to subtract 144 from both sides, and we end up with x squared equals 25. But we're not interested in what x squared is. We're interested in x. So we must take the square root of both sides. X equals 5. So here's another problem. We were asked to find the leg. Again, you can use a squared plus b squared equals c squared to find the leg. That is a problem for you to do. Set it up and solve and find that missing leg. Now, I want to teach you about a shortcut. A shortcut that you can use to solve for missing links in a right triangle is called Pythagorean triples. A Pythagorean triple consists of 3 positive integers. So let's pause there. That's going to be 3 positive numbers that are not fractions or decimals. 3 positive integers, a, b, and c, such that a squared plus b squared equals c squared. Another way to say that is it's 3 positive whole numbers that satisfy the Pythagorean theorem. The most popular one that you will see is 3, 4, 5. Because 3 squared plus 4 squared equals 5 squared. What makes Pythagorean triples special and how they help us solve problems is not only do the triples work, but all their multiples. We'll talk about that more in just a second. 3, 4, 5 is the most popular one, but others that you should memorize include 5, 12, 13, 8, 15, 17, 7, 24, 25, and 21, 20, and 29. Now, here we have a problem using Pythagorean triples, and you might say, well, Miss, 6 and 10 are nowhere on this list, and you're right, but there are multiples of one of our Pythagorean triples. So when we're looking at 6 and 10, what I need you to do is think of what is a number that goes into 6 and goes into 10. If you said 2, you're correct. So I want you to think of reducing 6 and 10 as you would a fraction. 6 is 3 times 2, and 10 is 5 times 2. You might recognize 3 and 5 here. So what are we missing? We're missing 4. But we can't just say we're missing 4. We're missing 4 times 2. We have to double it, and that will give us 8. So we're going to do the same process here. We have the sides 24 and 45. What is a number that will go into both 24 and 45? 3 goes into both 24 and 25. So if we think about what is 24 divided by 3, we get 8. 8 times 3 is 24, and 15 times 3 is 24. I believe 8 and 15 are on our list. So what are we missing? We're missing 17. But we're not missing 17 just plain. All the other sides were multiplied by 3. So we have to multiply 17 by 3, and we will get 51. Pythagorean triples are shortcuts, and they save you from having to use a squared plus b squared equals c squared for every problem. If you memorize them and recognize them, they're going to help you get to solutions super quickly. Thanks for watching this video. Hope you have a great rest of your day.